So, when you're first getting into Java concurrency, you're almost always taught one specific way to create a thread. But here's the thing, that classic method can back you into a corner and cause some major headaches down the line. Today, we're going to break down why that common approach is actually a bit of a trap and show you the modern, much more flexible way to handle threads in Java. All right, let's kick things off with a little puzzle. Take a look at this code. We've got a class, myWorker, and it needs to inherit some really important stuff from some important class. Simple enough. But we also want this worker to run on its own thread. So naturally, we try to make it extend thread as well. Makes perfect sense, right? Well, Java will throw an error. This code won't even compile. And that one little error, it gets right to the heart of the problem we're going to solve today. So what's really going on here? The issue comes from the number one way beginners are taught to create threads, by extending the thread class. I mean, it seems like the most direct way to do it, but it comes with a massive limitation that can really cause some design nightmares as your application gets bigger. This makes it crystal clear. Look at the left side, a class that just extends thread. Totally fine. Green check mark, we're good to go. But look at the right. The moment you try to extend another class and thread, nope, red X. That's because Java has a fundamental rule. A class can only have one parent. It can only extend one other class. The second you type extends thread, you've used up your one and only inheritance slot. You're stopped. Okay, so if extends thread is a dead end, what's the alternative? How do we fix this? Well, let me introduce you to the Runnable interface. This is the elegant solution. It's all about separating the what, the actual task you want to run, from the how, which is the thread that actually runs it. So what exactly is this runnable thing? It's actually incredibly simple. Think of it like a contract. Any class that says, hey, I implement Runnable is just making one single promise. I will provide a run method. That's it. A runnable object doesn't know how to start itself or manage a thread. It literally just holds the work that needs to be done. And that separation is precisely why Runnable is the way to go. First off, it instantly solves our inheritance problem. Your class is now free to extend whatever other class it needs to. It also just leads to way cleaner code because you're not mixing your task's logic with the machinery of a thread. This isn't just about being tidy. This is good object-oriented design, and it's the foundation for pretty much all modern concurrency frameworks in Java. Okay, so we've got our task defined using Runnable. It's like we've written up a to-do list. But a list can't do the work by itself, right? It needs a worker. So now, let's see how we connect our Runnable task to an actual thread to get the job done. And this brings up a really important question. If you're used to the old way, you just call the .start method on your thread class, and you're off to the races. But if you look at a runnable object, there's no .start method. So how in the world do we kick this thing off? This is the final piece of the puzzle. It's a super simple four-step process. Think of it this way. Step 1, you create your task. Just make a new instance of your runnable class. Step 2, you hire a worker. You create a plain old thread object. Step 3, you give the task to the worker. You do this by passing your task object right into the thread's constructor. And finally, step 4, you tell the worker to start. You call .start on the thread object, not on your runnable. Now, this runnable pattern is incredibly powerful. And the cool thing is, the way we write the code for it has gotten so much better over the years. Let's do a quick trip through time to see how this has evolved, from really verbose code to the super clean and concise Lambdas that we use today. This is the classic old-school approach. You'd literally create a whole new Java file for your class that implements Runnable. Then you'd create an instance of it and pass it to your thread. It works for sure, but man, it's a lot of code and ceremony for a task you might only need in one single place. Then, things got a little better with the anonymous inner class. Developers figured, why create a whole separate file if I'm only using this once? So instead, you could just define the Runnable and its run method right there, on the fly, exactly where you needed it. This cuts down on a ton of boilerplate and keeps the logic right where it's being used, a big improvement. And then, with Java 8, we got the absolute best way, the Lambda expression. This is where it gets really elegant. Because the Java compiler is smart enough to know that Runnable only has one method we need to worry about, the run method, we can just get rid of all the extra syntax. All the public, void run stuff, the class definition, it's all gone. We can just provide the code for the task directly. It's so clean and readable. And this whole evolution really points to a core idea in modern programming. The goal is to focus on your task, on the what, not all the ceremony and boilerplate code around it. Lambdas let you get straight to the point. All right, let's pull all this together with a quick recap. And pay attention here because this next slide is basically your go-to cheat sheet for this topic, whether you're studying for an exam or prepping for a technical interview. Let's put these two methods head to head. For inheritance, extends thread is a dead end. It uses up your one and only slot. Implements Runnable leaves you totally free. For flexibility, Runnable is the clear winner because it decouples your task from the thing that runs it. That's just great design. Which means for code style, Runnable is absolutely the modern preferred choice. So is there ever a good time to use extends thread? Maybe for a quick and dirty single-purpose thread in a test or something. But for any real, complex application, implements Runnable is the right choice every time. So there you have it. We've seen why extends thread can be a trap, and how implements Runnable, especially when you pair it with modern Lambdas, gives you a solution that's so much more flexible and powerful. So the question I'll leave you with is this. Now that you know the why behind it all, what part of your own code are you going to go back and refactor first? Thanks for watching.